Okay, so welcome back. This is the course in bioethics in the program of molecular and cellular, the master's in molecular and cell biology at St. Thomas University. Beginning always with a little prayer. Come, Holy Spirit, fill the hearts of your faithful and enkindle in us the fire of your divine love. Amen. All right. The other way. So, on Monday, we were talking about contraception and therapeutic sterilization, which functionally is seeking the same thing, which is to prevent conception, all right? But to do so artificially, because I keep mentioning that there's an alternative, which is natural, which is called natural family planning, and hopefully I'll be covering that next week. And I was mentioning that we have to consider one of the arguments against contraception is based on the humanity of sexual intercourse, so that it's not just an instinctive animal act, right, like the rest of nature, but a number of characteristics that make it human, that make it personal, intimate, and so forth, and lifelong, as a lifelong project together for the couple. And therefore, these two dimensions, these two ontological dimensions, ontological meaning pertaining to the being as such, to being human, which is the unitive and the procreative dimension. For example, in the rest of nature, animals that reproduce sexually, for them, it's strictly the procreative dimension, right? The reproduction. And it's driven by instincts, even though those instincts can be pretty sophisticated at times, including dances and songs and so forth, as we know in nature, right? The male or the female calling out and display and everything else, it looks pretty sophisticated behavior, but it's still driven by instinct. And the thing that is typically lacking in the rest of nature is the fidelity aspect, the aspect of that it's personal, there's a personal commitment, and so forth. So that goes more toward the unitive dimension, which is very human, including the fact that the woman may accept the man outside of ovulation, which really doesn't happen in nature, except for one exception that I know of, which I'll mention in a minute. But we see then that the human will is engaged and should be engaged, definitely, in human sexual intercourse, in contrast with the rest of nature, because they just are following instincts, all right? So the one exception I do want to mention is with chimpanzees, just in case you hear about this case. I don't want you coming back later and say, oh, Dr. Chaffee lied to us about this, not that no other female accepts, male accept during estrus, during ovulation, all right? Have you heard of the case of the chimpanzees? No? Okay, so they're also herd animals. They are, or clans or tribes, whatever they're called. Troops? Troop, yes, exactly, a troop, thank you. Right, and typically the troop is an alpha male and then he's got his females. And there's one case that I know of where the female may accept the male outside of ovulation, okay, outside of estrus. And, but it's still instinctive, which is this. It turns out that chimpanzees are pretty violent and the male in particular beats up on the female, okay? And therefore, the females have figured out that if they drain the male of testosterone, then his, not only his libido, but his aggressivity also goes down. So it's a way of pacifying the male. And they have figured this out. Not all of them, but some. And then I guess the mothers teach their daughters to do that behavior, because they also, like all primates, you know, we're very curious and we imitate. And we learn by rote and by imitation. Even as much as we hate to admit it, in that aspect, we're very similar to the other primates in that we also imitate a lot, right? What's going on, especially children to the ones they look up to. So the juvenile females will learn that type of behavior from the adult females in the troop. However, it is still instinctive. All right, and the instinct is basically a survival instinct for lessening the aggression on the males, particularly the alpha male. All right. Sorry? Dolphins? Really interesting. So the dolphins tend to be the male, the alpha male, can be aggressive. I didn't know that. Interesting. Okay. There it is. All right. So you see, always willing to learn something. All right, so now we're going to look at so I was saying then the bottom line with contraception is that it makes a radical separation, right, between the unitive and the procreative, whereby the couple may have the unitive, but prescind of or block out the procreative artificially. And therefore doing really ontological violence to those two dimensions that should be kept together. And they should be kept together at least by way of intention, all right? In other words, it doesn't mean, I keep saying, it doesn't mean that the human couple needs to have a child every 9 months, all right? It's rather the openness to the procreative dimension, the generosity of heart that elicits. In vitro fertilization is kind of the converse of contraception, in that it allows for the procreative without the unity. In other words, it separates, again, radically, artificially, the unitive from the procreative dimension, but in favor of procreation. In other words, because the fertilization is done in the lab precisely by the words in vitro, right, in the lab, then there doesn't need to be intercourse to have in vitro fertilization occur, all right? So it also separates the two in favor of procreation and compromising on the unitive dimension of human sexual intercourse. All right, so as always with bioethical issues, we look at the biology first and we look at the theological analysis or the ethical analysis. So a little background on the biology. This is kind of a standard diagram that I use for beginning of life issues, just to recall and once more the in vivo way of fertilization. In vivo meaning in life, in the actual body of the woman, which is the ampulla specifically, where fertilization normally occurs, and 5 to 7 days later, the actual implantation. So it's already that early embryonic development there, the first week of development, okay? So in contrast to in vitro, this is in vivo, meaning happening alive within the body of the woman. In vitro is a reference to in glass, vitro meaning glass, which is kind of historical because it used to be that the labware was all glass and was typically glass that could be autoclaved, all right? So it was either Pyrex or Corex were the two main brands, and I'm ancient enough to remember glass petri dishes and glass syringes and glass everything, all right? Today, and then there were, all the glassware was washed, rinsed, and then put in the autoclave, sterilized, and reused. So it was reusable. Today, that glass you can find in museums and stuff like that, and in old cabinets, but today everything is plastic, it's disposable, and comes in a bag that is sterile, and so on and so forth. So actually this should be called today, if we want to actualize it, it should be in plastico or something like that, because it's all disposable plastic. But the glass word stuck in Latin, which is in vitro. Just like when we talk about in vitro experiments, right, and so forth. It's in the lab, basically. It's a reference that the fertilization takes place in a lab in contrast to in the body. And therefore, it's necessarily artificial. It separates the fertilization process from the actual intercourse of the couple. And it can get pretty sophisticated to the level of simply the standard, let's say, minimal IVF technique is to put the eggs in the mature ova in a petri dish, or actually a flask, with a nutrient that mimics, the medium mimics the reproductive tract of the woman, the cervical mucus, and then insert there the sperm, all right? That's the standard, the least expensive procedure. That would only be about $15,000, $20,000 straight up. To the most sophisticated, which is actually injecting a single sperm inside the ovum with micro-manipulators, we'll see in a minute. And you can imagine this is obviously a micrograph, a microscopic photograph. You can see the egg here. Look at the, what is this? Exactly, that's the polar bodies. You can see still the zona pellucida, the corona retiata, right? And there's the needle, which is a glass needle, thin to the point of being like capillary thin, all right? And if we can magnify this for a moment, you can actually see the sperm here. Amazing. And this thing over here, this tube, which looks huge, it's only the size of the egg, so that's about 10 microns across. What is this? This is basically the tip of what would be a vacuum hose, all right? So this is actually, you see the pinching in here a little bit, very slight. Imagine the level of sophistication of this instrument. The egg, of course, is round and wet around and so forth. So to try to pinch it and penetrate it is going to be slippery, right? And it can damage the egg in the process. You don't want to compromise the membrane and so forth. You want to do the minimal insertion possible, insertion point. So the egg has to be held in place. And to hold it in place, there is this machine that is like a vacuum. It is a vacuum. So imagine the subtle amount of air or fluid that this vacuum needs to suck in there just to hold the egg in place without dropping it. Too little vacuum or too much vacuum sucking it in, right? Because the egg is also flexible. So that tells you a little bit the level of sophistication of these techniques, and that's why these things cost beginning with $20,000, $25,000 and up, depending on how much quality control is going to be done. This technique, by the way, is called ICSI, intracytoplasmic sperm injection. All right, that's the acronym. And moving forward, here's an example of the whole setup. It's an inverted microscope, so the revolver and the objectives are at the bottom to leave the top of the stage clear for manipulation. And the manipulation is done with what is called micro manipulators. You see them here, all right? And these macro manipulators are much more sophisticated than moving them by hand. Actually, there's a little servo rotor here. There's a motor that moves the stage vertically, horizontally, and you can see that the image is being projected on the screen. In this case, it's actually a morula, as you can see here, right? With the various blastomeres. And they're just basically checking the stage of development of this IVF baby, because the embryo also has to be incubated for some time. I'll get to that in a minute. So all this typically is in a sterile room, and the technicians are outside of this room watching the monitor somewhere on a screen. And they want to keep this sterile because they don't want any bacteria or fungi or anything getting in there. So it's pretty sophisticated. All right. Now, there are several stages for IVF. The first thing to be procured is we need basically the raw material. We need egg and sperm, right? So sperm is very easy to obtain. It's very cheap. On the utilitarian side, basically it involves masturbation. But the egg is difficult to obtain. Eggs are expensive, all right? So they do a process called a hyperovulation or hyperstimulation of the eggs, of the ovary, right? The woman that's going to undergo the treatment will be given fertility hormones. Typically, Clomid is the most popular one, but there are others. And basically what these hormones do is they stimulate the ovaries into maturing more than one egg at a time. Ovulating more than one. It could be 6, 8, a dozen, 2 dozen, 3 dozen, all right? Here is a hyperovulated ovary that may have a dozen eggs maturing. They actually swell up like this, like a grapefruit. So already that should call people's attention. It is dangerous, it is certainly painful, and it can be life-threatening because if that ovary bursts, what happens? Massive hemorrhage, right? Now the woman is bleeding and she has to be rushed to the hospital. I have one of my cousins, she retired recently, but she was a social worker for the Baptist hospital system here in Miami at South Miami Hospital on Dixie Highway down south near Kendall Drive. Anyway, she told me, Alfred, all the time I'm seeing these patients, these women, because the Baptist system has a very profitable in vitro clinic. Says all the time I'm going to see these women in the ICU unit, which their ovaries exploded, you know, and they're in danger of dying. And this hyperovulation is an extremely risky, dangerous thing. But there it is. It's part of the clinical process, okay? Also, what happens? Well, what happens is that what is fertilized is the zygote, is the egg, and then, but what gets implanted? What gets implanted is the blastocyst, right? Because no zygote is going to implant. You insert a zygote into the uterus, and the uterus will discard it. Why? Has no trophoblast, has no way of implanting, has no signaling, no matching tissue to do the implantation process. So the embryo needs that trophoblast in order to start the signaling for the implantation, okay? So a zygote will not implant, a morula will not implant, a blastocyst needs to implant, but normally that takes 5 to 7 days. Therefore, the fertilized egg, which is no longer an egg by definition because the egg is haploid, and with fertilization now that entity is diploid, okay? It's also key, the words have meaning. And when people talk about fertilized eggs, it's really a misnomer because that fertilized egg is now a zygote, which is a new entity, it's a new ontological entity. It's no longer part of the woman 100%, you know, it's no longer an egg. Anyway, once the egg is fertilized, we have the zygote. That entity needs to go through the developmental process for about 5 to 7 days to become a blastocyst and then be inserted into the uterus with the hope of implantation. Follow? So it's a separate procedure from the IVF actually has been done already. The fertilization has been done. So what happens is, well, they have incubators that are pretty sophisticated, has to be maintained at 37 degrees centigrade, which is body temperature, right? In the nutrient medium. And rotating, so this whole scaffolding here moves gently to keep the nutrients moving, suspended. And it has a double, first it has a glass door, then it has the other door for security and so forth. So this has to be maintained at that temperature for that time. All the various eggs that were fertilized from all the different clients and so forth in these different flasks. You hope that they keep the labels very straight so they don't switch and swap babies at this point, which has happened. All right. DNA will tell, the DNA analysis will tell that. Okay, so about on average 5 days later, they'll go back into the incubator and pull out Mrs. Jones' embryos to be implanted. Okay, so now comes the next step, which is attempted implantation. I say attempted implantation because not all take. Here is a diagram of a little bubble, if you will, which with 2 blastocysts that are inserted, yes, with a cannula all the way up into the uterus and then released there. By the way, the uterus needs to be at that stage where it's spongy, right, for accepting an implantation. And it may not be the same cycle where the woman hyperovulated because she has to recover from the trauma of the hyperovulation. So it may be 1 or 2 or 3 cycles later, right? You follow? For the uterus to be thickened again in the possibility of a natural implantation. At any rate, the blastocysts are released in the uterus with the hope that they implant. I keep saying the hope that they implant because no one really knows why, but 3 or 4 seems to be the magic number. In other words, on average, when the technicians insert 3 to 4 embryos, 1 on average implants, on average, okay? On average. So it means that the other 2 or 3 are discarded by the body of the woman. No one really knows why, but that's how it is. So again, there's shotgun here in that they will insert more than normally the couple wants 1 child at a time. Okay, twins, okay, we'll tolerate twins, but triplets or quadruplets, it's getting to be too many for the single pregnancy. Plus anything beyond a singleton, which is a single embryo pregnancy, becomes a high risk. All right, high risk pregnancy clinically can cause eclampsia, high blood pressure to the mother, et cetera, et cetera. A number of complications can happen. Typically preemies, premature babies, low birth weight at birth, and so forth. Okay, so there are complications. It's not a very simple, clean, easy technology. It's pretty sophisticated and pretty risky. All right, so we need to go back for a moment, and that's what this 12 means here. Let's say that in this cycle, the woman hyperovulated a dozen eggs for the sake of a number. So she hyperovulated a dozen, and these dozen eggs are going to be extracted for use for IVF. Typically, they will be fertilized right away, because the best egg is a fresh egg, all right? Now, for many years now, for decades, sperm has been cryopreserved. It can be cryopreserved because sperm has very little cytoplasm, and therefore very little water content, and it can thaw, freeze and thaw fairly easily. But eggs are a very different story because they have so much cytoplasm, therefore they have much more higher water volume, and the problem is in the freezing and the thawing, that back and forth can damage the membrane precisely if crystallization happens, because you know the water expands when it crystallizes, right? And so it would rupture the egg, the zygote at this point, once the IVF occurs, when freezing, but they won't know until they thaw out that embryo, and it will be mush because the membrane was compromised, but frozen, and so they won't know really until that embryo is thawed out. You follow me? You follow the argument? All right, so basically the best egg is a fresh egg, and therefore as soon as they are obtained, they will be fertilized by the sperm from the husband or the donor, because now you can buy sperm in catalogs. And within the past few years, the technique has become so sophisticated, and there's so many millions of dollars poured into this industry that the technologists finally managed to freeze human eggs. And now you see sometimes in the news every now and then, an actress or some famous woman who is postponing her decision to have children, but she wants to have the young eggs. So in her 20s, she'll go through IVF, she'll go through hyperovulation, and freeze her eggs, and then get implanted in her 30s or 40s or 50s or whenever she's finished with doing whatever she wanted to do earlier. You follow? So eggs can be frozen now, because the technique has become more sophisticated. At any rate, we have a dozen eggs that become fertilized, and now we have a dozen embryos. Of course, she's not going to get implanted a dozen, right? She's going to get implanted or attempted 4. 8 more are left over. So far, these are what they call spare embryos. So what do we do with the spare embryos? The industry freezes them. Cryopreservation, all right? So here's an example of cryopreservation. It happens in liquid nitrogen. What is the natural state of nitrogen? At STP, standard temperature and pressure. Right now we have STP, right? STP is 1 atmosphere of pressure at sea level. We're at, well, about maybe 10, 12 feet above sea level. Not significantly different to change the temperature or the pressure. And nitrogen at standard temperature and pressure is gas. In fact, we're breathing it right now, right? About 3/4 of the atmosphere of the air that we're breathing is nitrogen. It's called an inert gas. What does inert mean? We breathe it in and out. It does nothing to us in the gaseous state. It doesn't go into the tissues, not absorbed significantly by the alveoli. So we breathe it in and out, and we're done. Different from oxygen, right? Which we, with our alveoli absorb, and different from CO2, which our alveoli expel. Okay, all right, so nitrogen, the natural state is gas, but you know the gas laws, right? If you compress a gas or cool it down, then it goes into liquid. And if you keep compressing it or cooling it, it goes into solid. Example, water. Temperature range of water from 0 to 100 centigrade, the 3 states, right? So above 100 centigrade, water is vapor, gas. From 100 to 0, liquid. Below 0, solid. All right, so those are the gas laws. All right, now, so how do we get liquid nitrogen? Cool it down quite a bit to about minus 300, 270, I think it is, about minus 270 degrees Fahrenheit, which is only about 200 centigrade, minus 200. Minus 200. Ever been up north when it's freezing cold, like 32 degrees above, above plus 32 Fahrenheit, right? Below 32 Fahrenheit, it's very, very cold. So this is extremely cold. It's an order of magnitude more.
At that point, your face just starts burning.
Yes, yeah. Mm-hmm. At about 30 degrees, the breath starts freezing, and those of us with a beard starts getting icicles on the mustache and so forth. So essentially, anything that you put in liquid nitrogen essentially crystallizes. I'm saying crystallizing as a term, but it's not really crystal, but it solidifies rock hard, all right? You cut down the Brownian motion basically to 0 almost. Mm-hmm. It becomes hard rock hard, and that's what is done to these embryos. They're frozen like that until for later use. Why later use? Well, in the hypothetical case that I was talking about of the 12, how many were used for their first attempt? Keep the math simple, we used 4, so how many were left? 8. 8 went into the tank, right? Okay, so now she starts her pregnancy, she goes through the pregnancy, and only 1 implants, the other 3 are discarded. So she's got her pregnancy, first month, second month, third month, fifth month, and at some point, sadly, she loses that pregnancy. She has a miscarriage, okay? Nobody's fault, she had a miscarriage. So what happens? No problem. They go back to the clinic, they go back to the tanks, they pull out 4 more. Hopefully they're still from the same couple. They don't get the tubes confused. All right, so they pull out 4 more and they do a second attempt with 4. Now this time, instead of implanting 1, because 1 is an average, let's say that 3 implanted. Here's a sonogram of 3. Baby 1, baby 2, and the head of baby 3, which seems to be looking this way somehow. All right. So now she's got triplets. But they really only wanted 1. Okay. So the industry, no problem. You select. Abortion is legal, so just select which one you want. All right. Let's say that one is a boy and the other 2 are girls. Most couples will select the boy and discard the girls. It's in the population. You can look at the stats, and most couples out there, whatever country it is, they want the firstborn boy. Okay, so the euphemisms, this is called selective reduction. We're going to reduce the number of embryos in the pregnancy, and it's going to be selective because since you can choose, well, you can choose which ones you want. You don't have to go eeny, meeny, miny, mo. You can choose by the sex, or you can do some chromosomal analysis and take out some other characteristics that you want. Basically, we're getting pretty close to eugenics, right? I'm jumping in a little bit with the ethical analysis, but basically it's quality control. It's quality control on the embryo. Okay, so the selective reduction is offered by the industry because if some women get scared, oh, you're going to implant 2 or 3 or 4, don't worry. If more than one takes, we can just select them out and you decide which one. So it's getting into quality control. Again, keep in mind that these procedures cost $20, $30, $40, $50,000 each attempt. And therefore, they're getting something for the money, right? They're getting quality. And so it's quality control. And the quality control can be done at the genetic level at 2 stages, pre-implantation or after implantation. All right, so pre-implantation genetic diagnosis is actually PIGD. Oops. Pre-implantation is, remember the morula, we'll go back to the morula. What are the names of the individual cells? Blastomeres. And what's their potency? Totipotent, right? The same with the zygote, it's totipotent. By the time we get to the blastocyst, because there is cellular differentiation, the first level of differentiation, then we are no longer, the cells are no longer totipotent, they're pluripotent, right? The ICM, remember, the inner cell mass or the trophoblast. But these are totipotent. In fact, these are experiments that were done back over about a century ago. Have you ever heard of German Hans Spemann? Spemann was doing studies with frog embryos, and at the morula stage was disaggregating the cells of a morula, of a frog morula, and then he said, well, let's see what happens. He was essentially testing for potency of the cells. And it turns out that disaggregating the morula of an amphibian, each blastomere will grow a new frog, will eventually turn into a new tadpole, all right? And so basically it was saying that they're totipotent. They kind of revert back to the zygotic stage, all right? So it was interesting experiments in the lower vertebrates that can happen. But it turns out in the mammals can also happen. Of course, normally there is still the zona and the corona holding the cluster together, holding the integrity of the cumulus, right? Which explains, I guess, in an evolutionary sense, the reason for the zona and the corona is to keep those blastomeres together so that they don't disaggregate and form multiple pregnancies in each attempt. Okay, anyway, the point here is that technicians can pluck out one blastomere, let's say from the 8 cell stage or the 16 cell stage, right? Remember, it's geometric progression. So one blastomere, pluck it out, here it is in diagram, send it to the lab for chromosomal analysis, and then see if that blastomere is carrying any genetic predispositions for cancers, for diabetes. The list of genetic preconditions that we can test today is increasing and increasing and increasing because of the human genome has been deciphered. So we know what the normal is supposed to look like, and we can contrast abnormal sequences or check for abnormalities, right? Just do a blast, basically. So bottom line, we can do genetic quality control on the morula before the morula is implanted to see if that morula passes quality control. And in this example, for example, 2 pass and 2 did not pass. They had some kind of precondition, including, for example, oncogenes that we have, or proto-oncogenes that may never express, but they're there. So how do we know? How do we know that condition is actually going to express or not? We don't. But just in case, let's not implant them. You follow? So it's quality control. It's just very, very utilitarian quality control on the embryo. It can be done before the implantation, which saves the woman the process of abortion, or it can be done after implantation because, again, it is legal. All right? Yeah.
Would you say that at that stage, since there's no killing of an embryo, would you say that at that stage there's no, at least in an isolated sense, there's no ethical concern?
No, I wouldn't. I would say that there's definitely an ethical concern. Let me paraphrase what you said. You said, since at this stage, talking about the morula, for example, there's no embryo. There is. There's an early embryo, right? In fact, it's in the second stage of development.
Yeah, I'm sorry. I was referring to like the later.
There's no blastocyst, right? There's no blastocyst, there's no gastrula, all right? There's no fetus. So, but it is an early embryo from the zygote forward. It's an early embryo. So yes, there is, because that was my whole point about the immediate ensoulment. If the soul is granted at fertilization, not implantation or any, well, after, if the soul is granted at fertilization, then we have a human being. So it is a concern. And I can tell you, what do they do with these blastomeres that don't pass these morulas, that don't pass inspection, that don't pass quality control? They have several options. They can either flush them down the toilet, because it's not illegal. This is one of the least regulated industries in the world. Of course, they need one requirement: consent from the parents. I don't want that embryo. That's sufficient. Sign on the form, you don't want it? Okay, we'll take care of it. Flush it down the toilet. That's the cheapest way. Or if they have some scruples, some clinical scruples, they will send these embryos as hazardous waste. Hazardous waste, which is human tissue, for example. An appendectomy, that appendicitis is put in an orange bag with a biohazard symbol, and it's sent out as hazardous waste. What is done to that bag? Typically, they are incinerated, they're burnt, right? Hazardous waste is burnt. Okay, so that's the second option, but that costs the clinic something. And but at least I can tell the customers, the clients, oh no, we're not flushing your embryos down the toilet. We're sending them, you know, we're giving them the proper disposal as a hospital would do, which is hazardous waste. Right? There's a third option now, which is actually profitable for the clinic. They can donate the embryo to science and research, precisely to obtain embryonic stem cells. These are the source of embryonic stem cells. Donate, I put donate in quotations. Why? Because they certainly cannot sell the embryo, because that would be human trafficking, and that is illegal, all right? But they can donate the embryo to a lab, and the lab can compensate the clinic, not paying for the embryo, all right? Follow the technicalities. They're not paying the clinic for the embryo, but they're compensating the clinic, the in vitro clinic, for the time and labor and effort of having developed this embryo. So the clinic can say, well, you know, we spent $1,000 in the technician that did the IVF, and $3,000 in the preservation, the cryopreservation, and it was only $800 for the incubator because we were doing other incubations at the same time and so forth. But also they can get compensated for those expenses, which is not selling the embryo. You follow the technicalities? All right. So this industry has gotten very, very creative, very, very lucrative. And I can tell you it's a multi-billion-dollar industry, all right, throughout the world. It really is. It's amazing. Okay. So that's basically the process. Quality control before implantation with PIGD. Pre-implantation genetic diagnosis, or after implantation with a selective reduction, which is a procured abortion. Okay, let me stop for a moment. On the clinical side of things, because I've said a lot in a short time. Any questions, comments? So we got the basic technique of how it happens, right? All right, well, let's go for the bioethical analysis. I think it should be pretty obvious by now that the bioethical analysis is not going to be pretty, sadly, because of so many things that are happening here, so many violations of the dignity and the respect due to human beings, even if they are embryonic. All right, so it's done in a lab as opposed to natural procedure. Basically, we can say that an embryo is being manufactured in a lab. Right? Manufactured through very sophisticated lab techniques. Here's a little list for starters. These are considerations of practice, not of principle, but of practice. You know, so kind of pragmatical. The risk of hyperovulation, again, the risk on the woman, not on the man, on the woman. Easy to obtain sperm, right? Difficult to obtain eggs, and women are typically paid thousands of dollars for undergoing hyperovulation, even if they're not gonna have implanted. You find in a number of colleges, typically state colleges and universities throughout the US, every now and then you find brochures of clinics that are offering money for young women to donate their eggs, and they'll be compensated for the effort and the risk, all right? You find them also in airlines on the little flap of the seat. You find them typically as high-end, what we call high-glossy brochures, high-glossy, meaning that they appeal to high-end, what-to-do people, young women, particularly in colleges and universities. For example, they may give a young lady $10,000 for a standard hyperovulation cycle, just one. How many eggs you hyperovulated that cycle? We'll just take out those eggs, and here's $10,000. Thank you very much. But if she is, she has a high GPA, she may get $15,000 or $18,000. And if she's also an athlete, right, then she may get $25,000 for her eggs, because the industry is assuming that those are higher quality eggs coming from that higher quality woman. And it's out there. It's very tempting. Basically, I mean, it really is bartering with human life, okay? And you notice it's on the woman. It's on the woman. Go sell your sperm, see how much you're gonna get for it. Not $10,000. Now, if your sperm happens to be very vigorous and very potent, you may get a better price. And then your sperm is gonna be used in many clinics throughout the whole United States. So you may have you may be fertilizing hundreds of children out there, you don't know it, because once you donate the sperm at 100 million per ejaculation, you know, it's being used out there. Okay, it's tempting for young women to fall into this because, you know, $10,000, $20,000 could wipe out the student loan, or maybe 50% of the student loan, right? Could get a career for free. So these are issues, they're there. Like I said, the typical collection of sperm is by masturbation. The abortions that happen, these early losses due to failed implantation. Let's look at that in a little more detail. Because these are losses, right? Are they really natural losses? Can we say that this is a spontaneous abortion? Not really. It's not a spontaneous abortion, because these embryos wouldn't be there to begin with if it hadn't been for the in vitro technology, for the in vitro technique. You follow? So these embryos did not appear there naturally, right, through the fallopian tube down into the uterus. In fact, they appear there in the opposite direction, through the vagina into the uterus. And so there's nothing natural about this procedure. And therefore, these abortions, these early losses, right, on the ratio of 1 to 4 or 1 to 3, are not natural losses. They are procured abortions. They're procured abortions because If the couple doesn't know about it, certainly the industry knows the average. The industry knows very well that they are just playing on a statistic here, okay? And so these abortions are not spontaneous abortions, these are procured abortions. Do they tell the couple? Obviously not. They don't tell the couple because they're not trying to discourage the couple from going through the technology, right? So that's a very challenging thing. And on average, there will be 2 or 3 procured abortions for every in vitro child that is walking the earth today. And by the way, at this point, you ever heard the name Louise Brown? Louise Brown was the first test tube baby. Okay, Louise Brown. Yeah, in the UK. There she is. All right, and that's, I think, Dr. Steptoe, or maybe it's her father, I don't know. But Louise Brown was the first test tube baby, yes, in 1978, she was born. And she was actually, so you can see she was born in July of 78, right? So she was manufactured in 77 and born in 78. So 77 was when Doctors Edwards and Steptoe are the 2 inventors of this technique, these 2 medical doctors, Edwards and Steptoe. They're the ones who invented the technique in the UK and went through many trials until they finally got it right. And they got it right with Louise Brown because she was born alive, okay? But they had to wait dozens of years to prove the principle that IVF was working, all right? Of course, at that point, many couples signed up, couples typically who couldn't have children of their own and so forth, they signed up for IVF. And the industry has become more and more sophisticated over the decades. But why did they have to wait decades to prove the principle that IVF works? What was the ultimate? So Louise Brown, like I said, was born alive and grew as a child, normal child, adolescent, adult. But what needed to happen with Louise Brown? And why was it important that she were a female and not a male? Exactly. She had to achieve reproductive success biologically to prove that the technique worked. Because what if IVF does produce a new child, but these children are somehow sterile or infertile because of the technique? You follow? So the proof of principle, 100% for IVF, was that Louise Brown eventually married and had children. And that, then that industry took off. And they're very, very happy, Steptoe and Edwards, for getting Louise Brown. She married and she had children. And so now we can move forward with full confidence that this, in fact, a few years ago, Edwards and Steptoe actually received the Nobel Prize in medicine, right? So you can see that society at large praises this technique as a great advancement for these couples who cannot have children. I can tell you that even in the priesthood, there are a number of priests who think that this is actually pro-life, that this is good because couples that they know that they married for 10 years, Father, you married us and we've been trying, believe me, we've been trying, but we can't get pregnant. And so now we have an opportunity for IVF. And Father says, go for it, it's pro-life, I'll bless your children and I'll baptize them, etc., etc. And he has no clue because this was not taught at the seminary. Okay, all right. But moving forward then, you see yeah, sorry, okay.
Has there been any comments from the Vatican?
Yes, there are not one, but 2 documents actually that have come out. One in 1987, it's called Donum Vitae, which is kind of a sequel to Humanae Vitae. Humanae Vitae was in 68, no to contraception, yes to natural family planning. Donum Vitae is translated into the gift of life from Latin. It's in 1987, so 10 years after the technique was developed. Think of how late we are, right? It took 10 years for the Vatican to analyze this and realize, oops, no, this is breaking the double dimension of unitive and procreative. It's having the procreative without the unitive. And then they wasted a whole list of reasons why not, all right? So the document is there. I'll list it in a minute. Donum Vitae, the gift of life, from the Vatican, 1987. And then there was a follow-up in about 2007, I think, 2007, Dignitas Personae, the dignity of the human person, because more and more techniques were being developed, including stem cell research and all that, which happened in the 90s and 2000, early 2000s. So there was a follow-up document from the Vatican called The Dignity of the Human Person that talks about more techniques with manipulation, early manipulation of human embryos, including the whole issue of snowflake babies. Have you heard of snowflake babies? It's embryo rescue, rescuing the embryos that are cryopreserved. Because at some point, a number of couples walk away from the cryopreservation, right, from the frozen embryos, and then what to do with them. So there's a whole movement out there. It's called snowflakes to try to rescue these frozen human embryos. Let me continue with the list for a moment. Freezing and thawing of embryos. Again, the freezing and the thawing is not a 100%, and it's a shotgun industry all the way through. So those 8 embryos that were cryopreserved, there's no guarantee that all 8 would still be alive when we thaw them, all right? So there's really quite a bit, rather a high loss of embryos when they're thawed out. Not all of them survive the freezing and thawing process, even if we don't know exactly what it is that killed them. Was it the freezing or the actual thawing? We don't know until the embryo is actually thawed and put in the incubator to see if they grow, or put into a womb to see if they implant and so forth. So you got to follow the biology behind it. All right, other problems. At this point, since this industry has been going on for about 40 years now, all right, these frozen human embryos have been accumulating in these clinics. And in the United States alone, there's about 1 million frozen human embryos in in vitro clinics, about 1 million, only in the United States, okay? When I was doing this research back in the early 2000s, it was about 500,000. But those were only the clinics that responded to the survey and so forth. About half the clinics never responded to the survey of how many embryos they had frozen. It's proprietary information, confidential, et cetera, So that was a very kind of a low underestimate, that 500,000. And that was over a decade ago. So it's very easy to assume that it's probably over 1 million by now, because the industry continues to grow, all right? More and more couples are using this technique. Even if they can have children, they want to postpone. They want to postpone. All right, so that is generating this problem of the human embryos, what to do with frozen human embryos. What happens with parents, sometimes they divorce, and they'll fight for the embryo. If they want the embryo, maybe he wants them implanted into the new wife, but she doesn't want them implanted. And so they'll fight for the embryo just like they fight for the house, the car, and every other property. Because legally, they're not recognized as human beings, right? They're not legal persons, the embryos, but there's something materially, physically, they exist. So if they're not persons, what are they? They're things. All right, and so they belong, they're property, and they belong to this couple that generated them and created them and paid for the procedure. So it's in the divorce settlement, what to do with the embryos. Maybe they split them down the half, who knows. Sometimes couples, not divorcing, but they already have 1, 2, 3 children from the IVF. They have their family, thank you very much. We don't want any more children, but there's still 5 or 6 cryopreserved. What to do with them, what to do? They're paying, it's not free again, because this industry, there's nothing free, all right? They have to pay. It may be a small price, maybe $300, maybe $500 a year for the cryopreservation, but it's a service that the clinic is supplying, and they have to keep all the records in place. They have to supply the liquid nitrogen periodically and the personnel that does all that, and the security system to keep that cold room cold. Just last year, there was, no, 2 years ago actually, there was news of an in vitro clinic at the IVF clinic in Chicago. Was a major IVF clinic. their cold room overnight thawed out. Hundreds of embryos thawed out, died. It was a huge scandal. The lawsuits were mega, millions of dollars for this IVF clinic, all right? Because their safety system, and they probably had 2 or 3 layers of redundancy, but all 3 failed. And the fact is that on Monday morning, when they walked into that cold room, it was all thawed out, it was room temperature in there, and all the embryos were deader than dead. So a huge, big scandal. It was in the secular news all over the place, and the BBC hit the world news. Would you believe that about a week later, something identical happened at a clinic in California? No connection with the Chicago clinic. I think it was LA, I'm not sure, but it was in California, the same issue. Boom, the thing thawed out over the weekend, and all the redundancy systems failed. So, you know, it's not without risk. Anyway, what happens is at some point, a number of couples, because they're paying for this storage, just walk away. They walk away. Now, the industry is not going to go after them with a gun or anything. I'll put them in jail because, you know, for whatever the individual couple is paying, it's not worth the bad rap, right? They want to keep a positive image. They want to keep a pro-life image with the public. So the industry is going to absorb the loss, but now have to do something with those embryos because it's not theirs. They belong to that couple. They probably have in the contract, if you abandon the embryos, they're ours. So they have these alternatives that I mentioned: flush them down the toilet, send them to incineration, or donate them to science, donate them to research, and that's the source of embryonic stem cells, okay? That's the main source of embryonic stem cells here and many other places of the world. Now, here's another angle, which some people are not familiar with, and it's a natural, I was looking for an argument of natural selection, an argument from nature, from biology, all right? That had nothing to do with faith, God, or religion. And it dawned on me that these children are being denied natural selection. Again, because of the 100 million thing. Look at this, imagine this. In the in vivo fertilization, right? We know that theoretically, how many sperm do we need to fertilize one egg? One sperm, right? So 1-to-1 fertilization. However, functionally, in real life, for a human ejaculate to be considered clinically potent, right? Clinically potent, capable of fertilizing, that human ejaculate needs to have, on average, about 100 million sperm, right? 100 million sperm, it's actually 100 to 150 million. Take the low number. Why? Because the majority of sperm are going to get lost along the way, okay? First of all, when you think of the female reproductive tract and you put it to scale to a single sperm, which is microscopic, 1/10 of the 10 micron, of about 1 micron, swimming that distance is huge by proportion, all right? And that's why the whole issue of the vigor of the sperm, the capacitation, which actually the sperm completes its capacitation inside the female reproductive tract, all right? And becomes fully wiggly or able to wiggle itself all the way up to the ampulla once it's actually released inside the female reproductive tract. So it's a very sophisticated thing that happens in nature. But I want to go back to the statistic that bottom line, the selective pressure against human sperm is about 100 million to 1 against. And that's why we can say that on average, it will be the strongest, most vigorous sperm that fertilizes the egg, right? The most fit sperm overall, genetically speaking, and phenotypically, meaning that the flagellum is doing its thing, the acrosome is doing its thing, and every other structure of that sperm is functioning to the best. Because once fertilization happens, I talked about the acrosome reaction, right? Which is releasing of those enzymes to the proteases so that the nucleus, the haploid sperm pronucleus can be released inside the egg. But there's a counter reaction from the egg, all right? And it's called the cortical reaction. The cortical reaction is that the egg seals itself. It seals itself immediately upon the release of that pronucleus, the sperm pronucleus. The egg seals itself, all right, and becomes impermeable to a second sperm. Why? Well, because a nanosecond later, there's a second sperm. The second most vigorous sperm is right behind the first one. It's like a race. You have the first one who won, but the second person may be right on his or her toes, right? And so the egg seals itself. It's called cortical reaction. It has to do with calcium transport back and forth through the membrane. And so that only one sperm actually gets to release its nucleus. And so there's tremendous selective pressure is what I'm saying against the human sperm. That in the natural process. When we go through in vitro, we obviate all of that natural selection because we're just, first of all, there's a wash that happens once the semen is collected, right? That semen needs to be washed in the lab by a technician. And then the sperm is actually selected with a pipette and deposited inside the Petri dish, right? Or the flask. There's no way that this technician looking through a microscope is able to do the biochemical selection that occurs in vivo in the natural process of fertilization, all right? At most, the technician will look for complete flagella, whatever they can see through a light microscope. It's not even an electron microscope, it's simply a light microscope to see if they have a flagellum on them, stuff like that. It's a very gross type of check that is done on that washed sperm before that whole lot of sperm is inserted into the Petri dish, okay? And so once it's in that Petri dish, there's no telling which sperm is actually going to fertilize that egg. And it may not necessarily be the most capacitated, the most vigorous sperm, you follow? Because all the roadblocks have been essentially eliminated. And therefore, bottom line, with in vitro fertilization, we are denying that child to be the most vigorous child that he or she can be through the process of natural selection. We're denying natural selection to that child. Follow? And so it's an injustice. It's an injustice at two levels. It's an injustice at the level of the individual child, because that child is not necessarily the strongest, healthiest, most fit individual that he or she could be had the process gone naturally, all right? Remember, what's the natural rate of spontaneous abortion and miscarriage in the human? It's about 50%, depending on who you read. Some people put it up to 80%. What does that mean? That we have a natural selective process. So that on average, any one of us who are born are the best possible of all the siblings who would have been born instead of us. On average, we all have a sibling, a brother or a sister who didn't make it because they were less fit than we were, statistically. And those are the stats, all right? So think about it, it's sophisticated. The argument is a little sophisticated. It needs biology to understand it. But once you understand it, you're saying, wow, that's an injustice. Denying this child natural selection when they are totally at the beginning of the process, even before fertilization itself, okay? And so we're denying it to the child, and we're also denying it to the human species, because little by little, statistically, these IVF children who are now in the population, right? Little by little may be weakening the human species because they're not necessarily the most fit that would have been born in vivo. Another way of saying is that there may be a reason why this couple is not having children the natural way. It may be that either the egg or the sperm that are being produced are not fit enough to produce a healthy, normal human being. You follow? And so this industry is going against that process of natural selection for a vital process that belongs not just to us, but to the human species. It's like tampering with the human genome. Who has a right to do that? That's the patrimony of humanity. The human genome belongs to all humanity. Who has a right to go in there and manipulate that and do eugenics at the genetic level on the human genome? You follow? And so these are subtle but very real injustices that need to be called out. And so that's what I'm doing. I'm calling them out for you to consider. So, yeah, here is just reiterating that, of course, if we follow a utilitarian analysis, of course, IVF is going to be justified because the end justifies the means, right? And the end is getting this couple, this infertile couple, in the best case scenario, an infertile couple who are actually married and plan to stay married and so on and so forth, right? They're getting them a child because they themselves cannot have a child on their own. It could be something as simple as his sperm doesn't have a tail or has a reduced flagellum, or it's not producing 100 million, maybe it's only producing a few hundred or a few thousand, okay? And so you can see that from a utilitarian perspective, it could be justified because at the end of the day, it's procuring a child to a couple who cannot have children, right? But if we go from the principled perspective, which is what I'm promoting in this course, no, because the technique itself has to be justified. The means have to be justified. And there are all of these injustices that are occurring, okay? So, no, it's just giving an example of why utilitarian is not acceptable. But basically, the industry promotes, these are just photos from the internet, promotes this pro-life image. It's all about pastel pink and pastel blue. But that's in the front reception. The couple doesn't really know what happens behind in the lab, what is being done, all the gross manipulation of human life that is going on there. And even if they do, they may gloss over it because it's all about having that child, all right? All about having that child, which can become pretty intense. I can tell you, being a priest for 36 years, married many couples, counseled many married couples, many divorced couples. And when a couple cannot have children, it can get very intense. They really want to have that child. And if it costs them $20,000, $40,000, $50,000, they will pay for it. And it can get very intense for that couple. It's as if the marriage and the relationship depending on having that child. Not all, of course, but it can happen, all right? So the industry plays into that. More about using utilitarian. I think I've covered these things. Utilitarian becomes legalistic. You know, as long as it's legal, don't break the law. As long as it's legal. The problem with that argument is that many things that are unethical are not illegal. As, for example, I've given the example of adultery or even lying. You know, lying, unless it's under perjury, under oath, is not illegal. Yet, I hope that we all agree that it's unethical, right? Who of us would like to be lied at? Or lied to? All right, so the industry is what it is. It's getting bigger and bigger. And so I know that these arguments is a little bit like the shrimp, right? What is the shrimp? You notice, do you like eating shrimp, by the way? Do you like shrimp? Yeah, I love shrimp. What do we eat from the shrimp? Is the tail, biologically, is the abdomen, which is overgrown. It's disproportionate to the thorax and the head, or the cephalothorax of a crustacean. But why does the abdomen get so large? It's the muscle, because the shrimp is always swimming against the current. And it's developed that super large muscle, all right? So it's swimming against the current. I understand it's swimming against the current. And yet we need to do that because unless the shrimp swims against the current, then the shrimp gets washed away with the current. And it's important for us who have reason and will to not allow the current to sweep us because we have the capacity to think and to will what is right and what is good, even at the level of the means, all right? Before we get into the ends and paint ourselves into a corner, and now the couple comes, oh yes, we got our child father, but now, since we went through the in vitro that you told us, can you now tell us what to do with our spare embryos? Because we got 8 spare embryos in the freezer, and we don't know what to do with these 8 spare embryos. We don't want 8 children. So what to do with them? Okay, and the father goes, Didn't have the lesson. Didn't have the lesson. Okay, so those are my 2 points there. Natural selection. This fleshes it out again. It's repeating more or less a little bit of the same. You know, it really comes down to a manipulation of this early human life, which they cannot defend themselves, so they need advocacy, right? And it can become an issue of seeing these early human embryos as a thing, as a product. The industry supplies a service. The couple has the money to pay for the product, so they go ahead and engage in that contract. But really what's happening in the background of this industry more and more and more is, because of the quality control, it's a type of eugenics, you know, it's a type of eugenics. And it's not getting better, it's getting worse, precisely because it's not illegal to discard and to kill these unborn, so they can do all kinds of quality control. And then the prejudice of people is coming out by preferring boys against girls and so on and so forth. I just gave one reference here when eugenics is not new to the human race, right? We've seen it before. The last time it happened at the global level, it led to the Second World War, precisely because of a megalomaniac who wanted to eliminate one particular race at first. He thought that the Jews were a cancer of society and they had to be eliminated. And when he was making progress there, then he didn't stop there. He expanded into homosexuals, gypsies, and other defective people, first in Europe and then expanded into Northern Africa and so forth with Rommel and other of his henchmen, who continued Hitler's mentality of eugenics, all right? It spilled over into the US. I talked about Sanger and others in the 30s here, about 100 years ago, that eugenics movement even spilled into here. You may have heard of a lab, very famous lab up in New England called Cold Spring Harbor. Have you heard of Cold Spring Harbor? Yeah, Cold Spring Harbor had started as a eugenics lab 100 years ago, approximately, and then became the prestigious lab that is today. I think actually James Watson was living there when he retired, Cold Spring Harbor. They hold their annual conferences on the top level of biology.
Is there anything else you need to?
No, that's basically it. We have a few minutes still, so please feel free.
There was a hospital, I believe, that found out at some point that some of their like tissue samples and things, such like how they had flash analysis and things like that. Some of them, this was in Europe, some of them were actually obtained from a concentration camp.
Really, that tissue, huh? And somehow it slipped into the research environment, the research culture.
They actually gave the remains of Uriel.
Wow, yeah, right. You see, and that's why I brought up Nuremberg. You can see it more on trial online, but basically Nuremberg was the trial after the Second World War that tried the various colonels and leaders that they could trap. Supposedly Hitler committed suicide, so he was no longer available for trial. Many of his leaders did the same, but the ones that they could find, in Latin America and other parts of the world, right? These hunts were put on trial, and many were given life sentence precisely not to kill them because they were doing the killing, and it seemed not proper to kill them for having killed, right? And so they were given life sentences. But anyway, this was the scandal of humanity at the time, the Nuremberg, well, the concentration camps, which was eugenics. Eugenics continues. We cannot be fooled. We cannot be naive. Eugenics continues, but it has gone subterfuge. It has gone down to the microscopic level, all right? But eugenics certainly continues. There's an active eugenics movement going on throughout the world. And some of these IVF clinics are part of it. Wittingly or unwittingly, when they're doing quality control on a human embryo, that is eugenics because they're selecting, you know, who lives and who dies of the human embryos. So this is in vitro fertilization, the flip coin of contraception. But again, you see the indignity when those two dimensions of the human act of intercourse are separated. We're gonna run into problems because it's such a vital human interaction that occurs in human sexual intercourse that really we need to essentially leave it alone and not be interfering with it, certainly not with artificial techniques such as contraception or IVF, okay? I've spoken my piece. It's 3:30. If anyone has any other comments or questions, you feel to make them. Otherwise, okay, so anything really? No? Okay, pretty clear? Please.
On my thing, I have surrogate motherhood and embryo adoption. Is that for Monday?
Yes, so let me see. Let me pick it up because I want to talk about Monday. Let me pick it up on Monday and wrap it up then, all right? Yeah, thanks for bringing it up. So yeah, let me stop the video so that I can start the download. But hold on because we need to talk about Memorial Day Monday.